Okay, so this is the significant figures counting and rounding video. uh, First thing, definition of a significant figure. It's any number that increases accuracy of a measurement. All right, and we're going to go over counting first. So we use what is referred to as the USA rule for counting. Okay, now here it helps to know where your Atlantic Ocean is and your Pacific Ocean is. So let's start with the Atlantic side. Here's your Atlantic Ocean over here. Hope if I spelled it right. Okay, and Atlantic starts with an A. So we're going to start from the Atlantic side anytime there is an absent decimal. Anytime you see a number and there's no decimal, you're going to start on the Atlantic side, the right side. And you're going to move from right to left. Okay? If there is a present decimal, we're going to start on the Pacific side. Present, P, start on the left, work your way to the right. Okay, and what do I mean when I say work my way from one way or the other? So what we're going to do is we're going to skip all zeros until the first non-zero. So skip all zeros until the first non-zero. What is a non-zero? A non-zero is any number other than 0. 1, 2, 3, 4, 5, 6, 7, 8, or 9. Any of those are fine. Okay? So, for example, if we had the number 0.000345, right? We have a decimal present. So we're going to start on the Pacific side. We're going to start here and work our way towards the right. We are going to skip all these skip all these zeros. These are not important until we get to our first non-zero. Okay, 3 is our first non-zero. Then we're going to count everything after it. So we have 1 here, and 1 here. So we have 3 significant figures in that number. Okay, let's look at another one. Let's say we have 6.049. We have a decimal present. We're going to start on the left and work our way to the right. So our first non-zero is 6. And then we're going to count everything to the right of it. Okay, now some people mess up and say, well, this is a 0. We don't count that one. But because it's after the first non-zero, we're counting everything. Okay, so 6 is our first, 0 is our second, 4 is our third, and 9 is our fourth significant figure. So here we have 4 significant figures. Let's work on the other side. No decimals. 400. Okay? 400 does not have a decimal. It is understood to have a decimal, but it doesn't actually have one in the number. So we're going to start on the right, and we're going to work our way to the left. Skip all these zeros, and our first non-zero is the number 4. And then we're going to count everything to the left of it. There is nothing to the left of it, so we only have one significant figure in the number 400. Okay? Let's go over another one. Let's go with 250,300. Okay? Again, there's no decimal, so we're going to start on the right and work our way to the left. Skip these first zeros. Our first non-zero is the number 3, and then we're going to count everything to the left of it. So 3, 0, 2, and 5 are all significant. So we have 1, 2, 3, 4 significant figures. Okay. Uh, let's just do some quick examples. All right, without the math. Let's go 185 million. Well, there's no decimal, so we're going to skip all these zeros. And we have three significant numbers, three significant figures. Okay, let's do the next one. 0.00350096. Okay, we have a decimal. It's right there. So we're going to start on the left and work our way to the right. Cross out these zeros, and our first non-zero is the number 3. So we're going to count number 3 and everything to the right of it. So 3, 5, 0, 0, 9, and 6 are all significant here. So we have 1, 2, 3, 4, 5, 6 significant figures. Okay, what about in something in scientific notation? Let's say we have 2.60 times 10 to the 6th. Okay, is there a decimal? Yes. So I'm going to start on the left side, the Pacific side, and work our way to the right. Our first non-zero is the number 2. So we're going to count everything to the right of that as well. So we're going to count 2, the 6, and the 0. And we have 3 significant figures. I don't know what that extra decimal is for. Okay. That is counting significant figures. All right, so we've done counting. Let's do rounding. Okay, rounding significant figures. There are some rules that we have to follow. Okay, rule number 1. You're going to look to the right of the number being rounded, just like you do when you're rounding any other number. Okay, do not make this more difficult than it is. All right, because 95% of these rules are the exact same rules you've been using since probably 3rd or 4th grade when you learned how to round. Okay, rule number 2. And this is the one that you know is rather lengthy. So if the number to the right is, and we have several scenarios here. If that number is greater than 5, you're going to round up, just like you always have since 3rd grade. Okay? If that number is less than 5, you're going to round down, again, just like you always have. All right? Now, when it's 5, it becomes a little tricky. So if the number to the right is 5, then you're going to look to the next number, okay? So if the number is 5 and the following number is 0, round down, okay? And then the last scenario is if the number to the right of your number being rounded is 5, and the following number is a non-zero, round up. Okay? Some people like to think of it as looking at 2 different places, okay? Or sorry, the 2 places over. So if you have 4.353, right, and you're rounding to the 3, some people like to say, well, let's look at these 2 numbers, and if it's 51 or higher, then you round up. And if it's 50 or lower, you round down. Okay, that'll also work. But these are our rules here. All right, so it's no different than really rounding what you've always been doing. It's just the 5 gives people trouble, and it kind of makes them go haywire. So let's do some examples. Let's say that we have 0.03998. All right, and we want to round this to 3 significant figures. Okay, first thing we have to do is count to the 3rd significant figure. So you've got to be able to identify which one is the 3rd significant figure. So there is a decimal present right there. We're going to skip this 0, and we're going to go, that's 1, that's 2, and here is our 3rd significant figure, that 9 right there. So we're going to look to the number to the right. That number is greater than 5, so we're going to round up. Okay, we're going to round up, and our number is going to be 0.0400. Okay. We still have 3 significant figures there. All right. Let's say that we have 0.4063. Again, we have to identify the 3rd significant figure. We're going to skip this 0. We have 1, 2, 3. So the 6 here is our 3rd significant figure. We're going to look to the right. All right, and that is a 3. So we're going to round down. Okay. So our answer is 0.406. Now you may be asking, why didn't we change this 3 to a 0 like we did in the last example? We want to end with 3 significant figures. Here we end up with 3 significant figures, and here we end up with 3 significant figures. So you need to add zeros or take away zeros sometimes in order to get the proper number of significant figures. Okay, and through practice, I think we'll be fine with that. Let's do another example. Let's say we have 408,391. And again, we want 3 significant figures here. Okay. There is no decimal. So we're going to look at, we're going to start from the right. Okay. And we're going to say that we've got 1 here, 1 there, and 1 there. Okay, so this is our 3rd significant figure. Okay, so we're going to round there. Okay, and actually I screwed that up. My fault. Let's go back. Let's say that our number is actually 406,390. Okay, now we're still going to go from the right to the left, and we're going to skip that 0. So we have 1 here, 1 there, and this is our 3rd significant figure. Okay, so the 6 is our 3rd significant figure. We're going to look to the 3. The 3 tells the 6 to stay the same. So our answer is going to be 406,000. All right, a lot of people will just put 406. Okay, you cannot round 406,390 down to 406. Okay, it just mathematically is not possible. Okay, so do not forget to add the zeros when necessary. Now, these are not significant zeros, but they do add to the value. Okay, they do add to the value. So you need to make sure that if you're rounding a number that is, something large, like in the hundreds of thousands, you need to end up with something that is in the hundreds of thousands. Okay, this number right here, we still only have 1, 2, 3 significant figures. Okay, let's do one more example. All right, let's say we've got 399.52. Okay, We have a present decimal, so we're going to start on the left and work our way to the right. We have 1, 2, 3 significant figures there. So our third significant figure is that second 9. And we're going to look to the right. Okay, we see that it's a 5. Okay, so when we see that it's a 5, it tells us to look to the next number. Okay, this number right here is a non-zero. So when it's a non-zero, okay, non-zero, we round up. Okay, so 399.52 becomes 400. Now, this has only one significant figure, the 4. Okay, we need to make these two zeros significant. All right, the way we do that is to add a decimal. Okay, that changes the direction that we start on, and it changes whether those zeros are counted. If there is no decimal, okay, so we have two different scenarios here. If there is no decimal, we're going to start on the right because the decimal is absent, and we're going to skip these zeros, and we're only going to count to 4. Since the decimal is present in the second example, we're going to start on the left and count to 4 as our first non-zero, and then everything to the right of it as well. So now we have 3 significant figures here and only 1 significant figure there. Okay? That is counting and rounding significant figures.